So I want to talk about some properties of addition and multiplication that make working with them special when compared to division and subtraction. The first property I'm going to do is actually this idea of the commutative property, which basically means it doesn't matter in which order you do things. Like, look, for example, if you do 4 plus 2, you get 6. But if you do 2 plus 4, you still get 6. So it seems like when you add, it doesn't matter in which order you add. It works out just the same. In multiplication, it also works out. 4 times 2 is 8. 2 times 4 is also 8. So it doesn't really matter in which order you do it. It works even every time. So notice that this would not work if I was subtracting or dividing. If I did 4 divided by 2, I would get 2, right? But if you do 2 divided by 4, you actually get half. And by the way, half is the actual inverse of 2, because 2 over 1 is the same thing as 2. So look, the numbers are flipped. So if you flip the order in division, you get the opposite fraction, right? Not the opposite, the inverse fraction or the reciprocal. Now, with subtraction, you have the same problem. If you do 4 minus 2 versus 2 minus 4, let's see what happens there. You have to slash the sign to change the positive, and then change the sign of the numbers afterwards. That's how you do subtraction. But 4 minus 2, different signs. That means you have to find a difference. So the answer is going to be 2. Got to keep the sign the biggest, so it's going to be positive 2. This time, once again, the signs are different. So it's going to be 2, but the 4 is bigger with a negative sign, so it's going to be negative 2. So you got the opposite answer when you actually inverted the order with subtraction. So if you change the order in subtraction, you get the opposite answer. If you change the order in division, you get the inverse answer. Either way, it matters. And that's why order of operations matters, because in problems involving both adding and subtracting, or multiplication and division, or a combination of them, you can't just do it in whatever order you want because of subtraction and division. The order matters. But if all you have is multiplication and all you have is addition, then you're okay changing the order. So long as all you have is addition and all you have is multiplication. The order of operations still matters if you have both. You have to do all the multiplications first. And we're going to do a video on that order of operations as well. But remember, multiplication, if all you have is multiplication, it doesn't matter which order you do it. If all you have is addition, it doesn't matter which order you do it. Okay, there's an associative property to that, which is the associative property of addition and multiplication. That basically means it doesn't matter how you group things, the answer comes out the same. So look, for example, if you do 4 plus 2 plus 1, and you group the 4 and the 2 together, right? You see that here on the top. Then that will give you 6, which plus 1 is 7. But if instead you did 4 grouped and then plus 2 grouped with 1, you still get 4 plus 3, which is still 7. So it doesn't matter which way you group it, it comes out the same. The same thing happens in multiplication. 4 times 2 is 8, times 1 is 8. But if you had grouped the 2 and the 1 first, and you did 2 times 1 is 2, times 4, still 8. This is just a playoff of the commutative property, actually. This is why. It doesn't matter how you group the terms, the answer comes out the same. It totally matters with division and with subtraction. I'm not going to show you the examples, but you cannot do the same thing with them, which is, again, why the order of operations kind of matters. Lastly, we have these kinds of things called identity properties. And the identity property of addition basically means that adding 0 does absolutely nothing. So when you add 0 to a number, nothing changes. So that's what's called the identity. Your identity is preserved when you add 0, right? So any number plus 0 is just the same number. 0 plus 4 is 4. 0 plus 3 is 3. The identity property of multiplication is with 1, not with 0. Because when you multiply something by 1, nothing changes. So 4 times 1 is just 4. 3 times 1 is just 3, right? So you preserve the identity of the number when you multiply times 1. Now, of course, if that doesn't work, if you multiply times 0, because any number times 0 is just 0. And that's the zero product property, that no matter what, either number multiplied times 0 gives you 0. Anytime you have 0 times something, it just zeroes out the whole problem. The last property that I'm going to talk about is this idea of the distributive property of multiplication over addition. And this is going to matter a lot at the end of the year. But basically what that means is that when you have a term outside of parentheses and two terms added inside of parentheses, what you can do is distribute that number to both numbers which are inside of parentheses. So, and we're going to talk more about this at the end of the year. So I'm not too worried about it right now. But that's the same thing as saying that in this example, 4 times 2 plus 1 is the same thing as 4 times 2 plus 4 times 1, right? So essentially, you would multiply the number outside by each of the numbers inside and then add them together. So in this example, it would be 8 plus 4, which will give you 12. Or you can actually add the inside first and get 3 times 4 still gives you 12. All right, so that's kind of what the distributive property means. You can either work with the parentheses first if you can, and then multiply, or you can distribute the outside of the parentheses to the inside, and it still works out. The last concept is just a review of something that I actually mentioned on the last video, which is this idea of inverses. Additive inverses are numbers that are opposite to each other, because when you add them together, you get 0. So they're the ones which are equally far from each other on the number line, like -4 and 4. When you put them together, it cancels out, you get 0. But canceling out in multiplication is not the same thing. That's with the inverses. We talked about that too. Any number which is the inverse of the other, when you multiply them by each other, you're actually going to end up getting 1. So like, for example, 3 over 2 times 2 over 3. Because they are inverses, when you multiply them by each other, your answer is always going to be 1. By the way, this does not work if you create a denominator that's 0, because you cannot divide by 0. It is impossible to divide by 0. You get a non-existent answer. It's an unspecified answer. Okay? So those were the properties of operations with adding and multiplication, which are special, which are going to be useful as we go through the 7th grade. And this is going to become more apparent as we do problems throughout the year. I'm going to keep reminding you guys of this, but it's something that we should have learned by now. And so it's important to talk about it. And it's also useful if you're trying to do the additional PFA on rational numbers, because it goes over this.